Hi everyone, I'm Stephanie and I'm a PM on Cosmos DB. Today we will explore the piping hot world of monitoring and observability and how you can leverage our new log analytics workbook to help you put out any burning fires. So as engineers, we all know that fires are bound to happen. This is where observability comes in. In observability for Azure, we have three main pillars: metrics, which are near real-time analytics for monitoring your requests. This data is typically aggregated up at a minute plus grain. We also have logs, which are per request, more finer-grained raw logs with richer dimensions than metrics, and it is a paid offering. And finally, we have alerting, which allows you to trigger notifications on top of data sources like metrics and logs. For the scope of the session, we'll talk about log analytics and specifically dashboarding with Azure Monitor workbooks. Now, before we go into the workbook itself, let's quickly chat about some common issues or fires customers typically investigate. For example, I'd like to know what my expensive query operations are, and why am I being throttled, or how much of my workload is being throttled. What are my long-running requests? Do I have a hot partition? And how do I see my hot partition at the logical partition level? And do I have a storage SKU? Which partitions, if I do? These types of questions are exactly what our new log analytics workbooks integrations will help us answer. It is an out-of-box dashboarding visualization for our logs, and the best part is that it can easily be customized for your needs. So these are the types of questions we will want to answer with our log analytics workbook. So let's dive in. Let's say we have in our workbook for insights, we see that there is some spike that happened. Sometime around in March, around 10:30 p.m., we saw utilization spike up to 100%. And we want to investigate further about why that happened. Let's go into our log analytics workbook. Here, what you'll notice is that the time range, you can select the last 24 hours, or you can even select up to a custom time range, going back to whenever you know the incident occurred. In this case, I'll set it to the last 24 hours. You can also select your database and a specific container if you know where it is. One thing to note is that when you do turn on log analytics, you have to select a couple of different category groups like data plane request or partition key RU consumption in order for you to use this workbook. Additionally, we also have another feature called query full text query, where you can actually view the entire query deobfuscated for your Cosmos DB account. Now let's dive into a couple of different examples. For log analytics, if you want to see your logical partition based on your RU consumption, you could actually view, this is the exact query that we use within log analytics, but we actually have it here in the workbook for easier viewage. For example, we have here your logical partition. In this case, I have partition by sensor, and we see around this time, the sensor 2 is actually the highest out of all the partitions, and very little usage in the other ones. We could also see queries with the largest response lengths. So this query is querying the CDB data plane request table, and you could actually see the query text that I ran and the max response length. And this response length is in milliseconds. In addition to this, if you want to see what operations are taking longer than 3 milliseconds, you could also look into the data plane table and look for a duration greater than 3, and also summarized by client IP, so you know who actually queried and at what time. Also, you can look at storage. So if you want to see storage skewness, you can see, as mentioned above, that for my logical partition 2, where sensor ID equals 2, we actually see the usage is very, very high compared to the other logical partitions. So this could mean that at some point there was some spike of usage for this particular logical partition, and we want to investigate what happened there. To do that, we can actually see here the request charge also map up that we see in this particular one partition, we actually see a lot of request charges, and this is by physical partition. So partition key range ID is actually the physical partition, and just looking at the raw data, this is actually the top with request charge really pretty high compared to the other partitions. So now let's try to look into what could possibly be the culprit. At that point, you saw that normalized usage was very high, and we also saw high rates of 429s, which are throttled requests. So if we look here, actually most of the 429s that occurred were create operations, which tells us that during this time, around 10 or 11 p.m., there was a burst of create operations in our collections, which caused that spike. So you can then investigate further whether this was expected or was this some other workload that started running unexpectedly, which caused a spike. And finally, one more interesting thing is if you want to look at your queries or how to optimize it, you could also use log analytics to query the data plane request table to view every query text and also what the charge was for that particular query. So you can sort by largest request charge and then sort of use that to optimize particular queries. So if you hover over the exact query text, you can see that I ran a query where I ordered by light and temperature, and this is another one that you could optimize if it was very high. All right, and then one last thing I wanted to share was if at any moment you have, let's say you already have some log analytics queries, one really cool thing about workbooks is that you can edit this workbook and you can select edit, and then each of these items or groups can be edited, and you can add in your own queries if you already have some complex or queries specific to your workload. All you have to do is select this more. You can clone this particular group and then scroll down and select edit, and then actually you could just edit this query, copy and paste the query that you have already, and then run it, and it will actually save it for you. And then you can save this in your own log analytics workspace, which is pretty handy. All right. Now that we've actually troubleshooted what was the issue, let's go back and let's talk about costs with log analytics. So log analytics, as you saw, can do really great things for investigating and troubleshooting issues, but it can get quite expensive. And so this feature is actually charged by the amount of data that is ingested into the workspace, very granular. So for example, if you have 10,000 requests per second, in one given hour, you could actually go to about 14 million requests, which is actually pretty high in terms of data ingested into the workspace. So to help optimize costs, we now have transformations in Azure Monitor, which will allow you to modify or filter out incoming data before it is sent to your log analytics workspace. With these transformations, you will be able to delete any unused columns, decrease data that is ingested into the workspace via filtering out entries that actually don't fall into your criteria, and things like only 429s or requests that fall above a particular threshold, and even creating new columns or aggregating data. Let's go over how to add transformations to your workspace. So here we have our log analytics workspace. What you'll do is go under settings and under tables, and if you scroll down, you'll be able to go to see our Cosmos DB log analytics tables. We have a couple of them for NoSQL API. Some that are relevant are the CDB data plane table, the partition key RU consumption table, and the partition key statistics table. So for this exercise, we'll look at the data plane request table. So you can scroll, and then you can select the edit transformation. In this case, you'll hit next, and I've already created a transformation, but you can hit transformation editor. And this actually gives you the table that we'll be querying. So if you query source, which is the base table, source will give you a lot of details, things like your account, the time generated, activity ID, client IP, connection mode, database name, how long the request took to execute, operation name, partition ID, and a bunch of other handy information. So what we'll do is actually we want to compress this table. So I'll copy over a sample query here, where just taking a quick look at the actual table, we see potentially we might not need some of these columns like key type, something that maybe not very valuable for me right now. Connection mode, if I'm running direct mode and I'm using the SDK, I probably don't need to investigate that. And then I could also remove type and tenant ID, things that are just taking a little bit more data into our workspace. So if I run this, you can actually see that the table is quite small compared to where it started. And then what if I only want to look at requests where duration or the time it took to run the request is actually only 200 milliseconds. So this actually gave us a pretty small table, but what if we want to further filter out rows that are coming in, and we could actually use a property called response length. What if we only wanted to look at a request where response length was actually greater than 1,000? In this case, this actually lowers down the results significantly, which actually gives us a lot more savings and optimizations into the data generated into our log analytics workspace. So now that we have our transformation applied to our source table, we can then hit apply, run the query, and then you can select apply. And I've already done this for this particular resource, but it will take about 30 minutes for the KQL transformation to be applied to your workspace, and then you'll be able to have a much more cost optimized logs. Thank you so much for your time, and I hope I was able to help you extinguish any fires in your service.